Okay, so we're into chapter 12 today. We're going to look at polynomials, which is really previewing what we're doing in the fall. You have already worked with polynomials a lot. When we get to the real course of algebra, we're just working with them tons and more complicated polynomials. So a polynomial, what is it? Poly, there's a poly in polynomial, which usually means what? Poly means many, right? Yeah. So usually many, although we have these things called monomials that are in this class called polynomials. And what does mono mean? What? One. Okay. So monomial is a polynomial. It's kind of like a square is a rectangle, but not every rectangle is a square, right? Bless you. So a monomial, what do you think it is? Can someone give us an example? Nico.
Something with
What do you think? Check.
something with more than 4 sides.
Oh, I'm talking about a monomial. We're not talking about geometric shapes. Anybody give me an example of a polynomial or a monomial? What do you think? You're going to be surprised then to know, Anthony. No, we're not talking about geometric shapes. We're talking just about terms. That's it, terms. Can you give me a term? In math, what would a term look like? Jeremy? Yeah, just give me a single term.
Like as in numbers?
It could be, so give me a number.
6.
Good, so it could be just a number. That's a term, right? One term is a monomial. And it could be, there's the example of a number 7. It's not always just a number, though. It could be more than just a number. Can someone give us something more than just a number, Sophia?
3x.
He says 3x. Very good, 3x. Now 3x is a monomial too. Let's see if we have one. Oh, look at that. Ding, 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 ding. You just won a prize. 3x is there. Okay, so 3x is considered a monomial. It's one thing that could be added to another thing, right? So in the case of 3x, what could I add to 3x and then end up with more x's? I hear somebody saying 2x's. So 3x plus 2x, those are like terms, right? So they could become 5x together when you combine them. What about 7? Could I combine 7 plus 3x?
No.
No, because they are not like terms, right? So a monomial is a term that could be added to other terms. It can be really complicated, a little product that's really complicated, like 4xy squared. 4xy squared could be added to 6xy squared. As long as we have the same variable expression, right, multiplied to the number, then we can add them. 4xy squared plus 6xy squared is, what is 4xy squared plus 6xy squared? 10xy squared. Just add them, right? It's like you're taking a bag of candy and the type of candy you have is xy squared. 3x is a different type of candy. Okay? So a monomial has one term. What do you think we would call a polynomial with 2 terms? The prefix meaning 2. Like you have 2 wheels on your bicycle, so it would be a binomial. Binomial has 2 terms. 2 terms like 3 plus x. 3 plus x is simplified because unless I know what x is, I have to leave it like this. 3 plus x. There's no simpler way to say it. Why is 3 plus x not 3x? Casey?
They're not like terms.
They're not like terms, you can't add them. And Michael?
3x is multiplication.
Good. 3x says I'm multiplying 3 times x, and 3 plus x is not multiplication. That's why. Okay? We could have more complicated binomials like 3x minus 4y. Again, those
Like
cannot
zeros.
be combined. What?
We can like stuff like this in here.
You've worked with these types of things already this year. 3x plus 2x squared. Now those both have a variable x, right?
So
3x. What's the exponent of the x here with 3x? Who can tell us? Lexi? 1. So when you don't see an exponent, we have one x variable there. That's what that's saying. It's the invisible exponent 1. And then we have 2x squared. So could we combine these two? 3x plus 2x squared?
no.
No, they don't have the same exponent, so they're really different things. So if you give me a number, somebody give me a number, any number, Mary.
6.
7, she says 7. So if x was 7, imagine we have 3 7s here, but to the right we have 2 49s. Those are different things, 7 and 49. Even though they both have that factor of 7 in them, they're different things, aren't they? So that's why we cannot combine those two. Okay? And who can guess what the name is of a polynomial that has 3 terms? Anthony. Trinomial. 3 terms being added together. So we could have x squared plus 2x plus 6. That's just an example. Now we've said that a polynomial is the sum of terms. Does anyone see something up here that doesn't look like the sum of terms? Which one of these expressions doesn't look like the sum of terms? Bella? What? Okay, well, let's look at the binomials. Are there any binomials that don't look like a sum? Tessa? 3x minus 4y. Okay, so what did we learn about subtraction this year? Subtraction is just, right, let's say adding the opposite. So when we look at this term here, this 4y, this is not 4y. That term is actually, everyone, negative 4y. We're combining negative 4y with 3x. So when we're talking polynomials terms, we always look at the sign that precedes the term. The sign is either positive or negative. Okay. We're going to now write polynomials in standard form. So here's a trinomial. And leave a little space because we need to define standard form. What is that? So look at this trinomial. This trinomial is not in standard form. So I want you to think about how we could rearrange it so that there's some logic behind the rearrangement. And then we'll say what standard form really is. Who thinks you have a way of arranging these that might be standard form? Can someone rearrange them in a way that you think is logical and it might be standard form if you do it this way? Anthony?
Maybe simplifying the x's.
Well, how could you simplify these x's right here?
Since it's x to the third power will be negative, we combine that with x's.
Actually, the power is not negative. The power here is positive and the power here is positive. But this whole term is a negative term, isn't it? Negative. How many x squareds do we have here?
1.
X squareds? We really have 1, right? Oops, I'm out of sync. Let me sync this. There's a 1 there, and there's also a 1 in front of that variable too. There's always a 1 in front of a variable that's by itself. That invisible coefficient there. Can anyone think of a way you might rearrange these? Or shall I just give you the definition? Nico?
X, 1x to the third plus negative 1.
Isn't the x to the third negative already?
Yeah.
Oh, yeah.
So Nico thinks this might be standard form because there's more x's in what, the first term? And you are absolutely right, Nico. That is how you put it in standard form. Good job. So the exponents, the highest degreed exponents go first. So the term with the highest degreed exponent was the x to the third, the negative x to the third. So it goes first. And then we go to the next highest degreed exponent, which was a positive x squared, right? And then we go to this one, which doesn't even have a variable attached. So if it did have a variable, what variable, or if it had the x, what exponent would make that x turn into a 1? Do you remember? Mary? 0, right? So if it had a variable right now, it would be raised to the 0 because 12 is just a constant 12, isn't it? So that would be considered the lowest degree term. It's a 0 degree term. See that? Has a 0 with its exponent, which you don't even see here. Okay, Lex. The reason the negative is in front of the x to the third is that's where there was a negative in the original expression, right? There was no negative in front of the 12, so what sign does the 12 have? Positive. But when we put it over here in the last place, then we need to show the sign because it's in the last place now, right? Okay, go ahead and put this second one into standard.
I got 6x to the third minus 4x to the fourth minus 4x minus 1.
And thumbs up if you agree. Wow, there's a little bit of a problem in this actually. There are actually two little problems I see here. And can someone name a problem that you see, Chad?
The 6x to the exponent of 3 is switched with the 4x to the exponent of 4.
Right.
Because the
This one,
exponent is larger.
right, this one has a higher exponent. So negative 4x to the fourth plus 6x to the third. And then he has negative 4x. And he has negative 1. What's the second issue here? Do you see the second problem? Riley? All positive? All addition all the way across? Not necessarily. We have to carry the signs. So when we look at the negative 4x to the fourth, that was negative. When we look at the 6x cubed, that was positive. So that matches here. When we look at the 4x, was it negative?
Yeah.
It was. And when we look at the 1, was it negative?
No.
So there's the problem. You've got to make that positive. So carry the sign. This first term 1, I don't see a visible sign, so the sign is positive, right? So we have to write plus. Write each in standard form and classify by number of terms. And then come back and check your work. Thing then. So here we have your simplified expressions. Actually, they're in standard form, and we classified them by number of terms. And now we're going to see some expressions that could be simplified. How do we simplify a polynomial? Look at this polynomial A. Is there a way you could simplify what you see? It says 5a plus 9a squared minus a squared plus 3a squared.
Yeah.
Is there a way to simplify that, Jeremy?
Since it's negative a squared, you can subtract from the other a squared and just have a squared.
How many are here where it says negative a squared?
2.
Are there 2 here?
It's
What's the number that goes in front of this variable? 1, right? 1. There's a 1 there. So we end up with 9a squared minus 1a squared. Can we simplify that?
Yes.
How many do we have? 8a squared. So we now have 8a squared, and we still have that over there, and 5a here. I'm just bringing down the other terms, right? So is there another way we could simplify this? What's the other way, Izzy? Do you see any variables with the same variable, same exponent? And you get 11. So these two are the same, they're considered like terms. They have the same variable to the same exponent. So they're like terms. We have 11a squared, and we still have 5a plus 11a squared. So how many, what do we have now? Okay, the a's, this has an exponent of 1, that has an exponent of 2, so we cannot combine them. They're not like terms, but we can write it in standard form, which is 11a squared plus 5a, binomial. Okay, so when we simplify, we combine like terms, and then we put the answer in standard form. Okay, so we distributed first, and then combined like terms, okay? And you're going to try these two. I'm coming around to check. Leave your book open until I've checked it. And there's your assignment.